Hello students, today in Metallurgy Part 3 we are going to learn about the reduction of metal oxides through smelting, reduction by carbon, reduction by hydrogen, reduction by metal and auto reduction. Let us recall what metallurgy is. Metallurgy is a process involved in the extraction of metals from their ores. This can take place in three different steps. One is concentration of the ore. Secondly, it is the extraction of the crude metal, and thirdly, it is by the refining of the crude metal we can get the pure metal. After the process of concentration of the ore, which involves crushing and concentration of the ore, we proceed on to the extraction of the crude metal. This can be done in two steps. The first step will be conversion of the ore into its oxide. Metallic ore can be converted into its oxide by the process of roasting and through calcination. The second step involved in the extraction of the crude metal will be through the reduction of the metal oxide. Reduction is a process of removal of oxygen from the metal oxide. This can be done in various steps. By smelting, reduction by carbon, reduction by hydrogen, reduction by using a metal, or through auto reduction. There are different reducing agents that can be used in the process of reduction of the metal oxide. The highly reactive metals like sodium, potassium, aluminium cannot use carbon as a reducing agent because the oxides of sodium, potassium, aluminium are more stable than the oxides of carbon, which is carbon monoxide, carbon dioxide. So, thermodynamically, the reaction will not be feasible. This will be dealt in the next video on Elegham's diagram. In the case of zinc oxide, aluminium oxide, carbon monoxide can be used as a reducing agent. The other reducing agents we can use will be hydrogen, sodium, aluminium, etc. Smelting. Smelting is a process by which a metal is obtained from its ore by heating. You can remember it from this word smelting. Remove the S and smelting is nothing but melting, which takes place by heating the ore. You take the concentrated ore and it is mixed with flux and the reducing agent to be used. Flux is nothing but a chemical substance that forms easily a fusible slag with gangue. Slag is something that gets precipitated, and reducing agent that can be used depending upon the metal oxide can be carbon monoxide, hydrogen, aluminium or sodium. In the case of reduction of oxide to iron, we can use carbon monoxide as a reducing agent. Let's take an example of iron oxide Fe2O3, which is in the solid state. You reduce it with carbon monoxide in the gaseous form in a smelting furnace where iron, the metal, is got and carbon dioxide is released. In the reduction of oxide of iron, we use limestone as a flux. The limestone, which is calcium carbonate, decomposes into calcium oxide and carbon dioxide. This calcium oxide is otherwise called as quicklime and it acts as a basic flux. The calcium oxide, which is in the solid form, the basic flux, reacts with the impurities gangue particles with the formula SiO2 and forms the slag CaSiO3, a fusible slag. SiO2 is acidic in nature. The slag particles settle down and can be removed. This is for the reduction of oxide of iron by using carbon monoxide. Let us see the extraction of copper by the smelting process. In the periodic table, we find in period number 4 and group number 11, copper is placed. So the position of copper in the periodic table is period number 4 and group number 11. This copper is present in the Earth's crust as copper ore with the name copper pyrite and formula CuFeS2. Now, after the concentration of the ore, this concentrated ore is mixed with oxygen in a reverberatory furnace where a high temperature is being applied and the copper gets separated as its sulfide Cu2S and the iron in the concentrated ore gets separated as FeS, iron sulfide. The iron sulfide in the same reverberatory furnace mixes with oxygen and changes over into iron oxide. The sulfur gets oxidized to sulfur dioxide. So the iron sulfide is changed over into iron oxide, and there is a little bit of unreacted iron sulfide. FeO, which is basic in nature, reacts with SiO2, which is the acidic flux which is being present, and it forms the slag FeSiO3, which can be removed. The remaining unreacted FeS and copper sulfide Cu2S are present in the mutually soluble form, and this is called as copper matte. The copper matte is sent into the Bessemer converter. The Bessemer converter is pear-shaped container with a basic lining, and hot air gets into the molten matte and sand through tires. The reaction that takes place inside the Bessemer converter will be the copper sulfide reacts with oxygen and changes over into copper oxide and sulfur dioxide is liberated. The copper oxide reacts with the unreacted remaining copper sulfide Cu2S and it forms molten copper and sulfur dioxide is evolved. This sulfur dioxide which is evolved through the molten copper on cooling forms blister-like appearance and hence it is called as blister copper. The unreacted FeS present in the copper matte is oxidized to FeO, which reacts with the flux SiO2 and forms the slag FeSiO3, which can be removed. Among the various methods of the reduction of metal oxide, let's discuss the reduction by carbon. Reduction by carbon is applied to metals which do not form carbides with carbon at reduction temperature. Why not apply to metals which form carbides? Metallic carbides are stable and converting them to the metallic forms is very difficult. Example, titanium, tungsten. When it forms the carbides, titanium carbide and tungsten carbide, it's very difficult to convert them back into the metallic form. Now the principle behind this reduction by carbon will be the oxide ore is mixed with coal or coke at high temperature in the blast furnace where the metal is separated with carbon monoxide gas being liberated. An example of this would be zinc oxide, which is the oxide ore, is treated with coal or coke in the blast furnace where a very high temperature is being produced and the zinc oxide gets reduced to zinc in the solid form and carbon monoxide is liberated. Now for you to understand how to balance this one, this is a self-balanced equation. In Mn3O4, it is reduced by carbon, we get Mn in the solid form and carbon monoxide being released. To balance this equation, we'll have to find out how many oxygen atoms are present in the ore. The 4 oxygen atoms combines with 4 carbon atoms and hence on the product side we will write it down as 4CO. So it gets balanced. Now Mn3 is present in Mn3O4, so on the product side we will write it down as 3Mn. The next equation, Cr2O3 in the solid state is reduced by carbon in the blast furnace, and chromium gets separated, leaving behind carbon monoxide as a gas. To balance this one, there are 3 oxygen atoms present in Cr2O3, which is taken up by 3 carbon atoms and forms 3CO. In the ore, we have Cr2O3. So 2 atoms of chromium are present, which can be balanced on the product side with 2 atoms of chromium. Reduction by hydrogen. This is applicable to oxides of metals like iron, lead, copper, having less electropositive character than hydrogen. Ag2O, the concentrated ore, is treated with hydrogen, the reducing agent, where silver is precipitated and water is obtained. H2O is obtained. To balance this, Ag2 is present in Ag2O. So, on the product side, we write it as 2Ag. Hydrogen is the reducing agent being used here. In Fe3O4, iron oxide is being reduced with hydrogen, H2 in the gaseous state, and iron in the solid form is obtained, precipitated, and water in the liquid form is given out. For the reduction of nickel, we use water gas. Water gas is a mixture of carbon monoxide and hydrogen. So, nickel oxide can be reduced with the help of water gas, which is a mixture of carbon monoxide and hydrogen, to form nickel in the solid form, carbon dioxide in the gaseous form, and water in the liquid form. Let us see the reduction by metal. With this is specially used for Cr2O3 chromite ore, which is being reduced in a process called as aluminothermite process. The metallic oxide is mixed with aluminium powder, which yields metal and Al2O3. For the reaction to take place, a high ignition temperature is needed, and hence an ignition mixture is added to initiate the burning. The ignition mixture that is being used is magnesium and BaO2, barium peroxide, is being used. Magnesium and barium peroxide, when it reacts, produces barium oxide and magnesium oxide, and a very high temperature is evolved of 2400 degrees Celsius. The reaction enthalpy is also found to be 852 kilojoules per mole. This large amount of heat that is produced facilitates the reduction of chromium oxide to chromium. This takes place in the aluminothermite process. In the aluminothermite process, we have a container which is filled up with sand, and the fire clay crucible is present. Inside the fire clay crucible, we take chromium oxide and aluminium. On the top of it, we have barium peroxide and magnesium. When this is being ignited, this large amount of heat which is produced starts igniting Cr2O3 and aluminium. And the reaction that takes place inside the aluminothermite process will be Cr2O3 plus Al with a large amount of heat that is produced changes over into chromium and Al2O3, or Cr2O3 gets reduced to the metal chromium in this process. The active metals of 1A and 2A, sodium, potassium, calcium, are also used to reduce metal oxides to metal. For example, B2O3 is reduced with sodium as a reducing agent to form boron and sodium peroxide. Same way, rubidium oxide is reduced with magnesium to rubidium and magnesium oxide. Titanium oxide gets reduced with magnesium to titanium and magnesium oxide is formed. Thorium oxide gets reduced to thorium with the help of calcium as a reducing agent, and calcium oxide is also formed at the temperature 1250 Kelvin. Auto reduction. The reduction of the ore of mercury, cinnabar, HES, takes place due to auto reduction. As the word implies, auto stands for takes place by itself. HGS, mercuric sulfide, when roasted with oxygen, undergoes auto reduction and forms mercury in the liquid state, the only liquid metal, and sulfur dioxide, which is in the gaseous state. This reaction is called auto reduction of cinnabar or the ore of mercury. Thank you.